Hello everyone, welcome to my channel. Today in this video I'll be starting a new unit, that is our unit 10, alcohols, phenols and ethers. Now in this unit we will be studying the organic compounds containing oxygen. Now there are a large number of organic compounds containing oxygen. In organic compounds, the oxygen is present in the form of different functional groups. In this unit, we will study about the organic compounds belonging to our alcohol, phenol, and ether families, and all the three compounds contain oxygen containing functional groups. Now, if we study the family name, the family name here, the common name, and then if we check the IUPAC name here, are alcohol, phenol, and ether. They are commonly known as alcohol, phenol, and ether. In the IUPAC name, this also will be known as alkanol. Phenol will also be simply referred to as phenol, and ether in the IUPAC name, the family name is known as alkoxy alkane. Now, the general structure of our alcohol is ROH. Here it is replaced by an aryl group OH, and then here it will be RORH. Now, here, the functional group in alcohol is, this is the general structure, and the functional group in alcohol is the OH group. This is the alcoholic group. Even in alcohol, the functional group is OH. This is alcoholic group. This is the phenolic group. And then in ether, the functional group is OR, the alkoxy group. Now, here, firstly, we'll be discussing alcohols and phenols, and in the later videos, I'll be explaining the family of ethers. Now, if we study alcohol and phenols are formed when a hydrogen atom from a hydrocarbon, like it is aliphatic for alcohol and aromatic for phenol, respectively, is replaced by an hydroxyl group OH. Therefore, we'll be getting here our ROH and the aromatic OH, that is referred to as our phenol. Now, if we check the classification of our alcohol and phenols, in alcohols, the OH group, the ROH group is attached to an sp3 hybridized carbon atom. It is attached to an sp3 hybridized carbon atom, and thus we can refer these alcohols as primary, secondary, and tertiary alcohols. Let's first check out the primary alcohol, OH. Our carbon atom here is sp3 hybridized. The OH group is attached to an sp3 hybridized carbon atom. It is referred to as primary. The secondary alcohol will be attached to two carbon atoms. This is our secondary alcohol. And then our tertiary alcohol is the sp3 hybridized carbon atom is attached to 3 more carbon atoms here. Each of these carbon atoms are all sp3 hybridized. This is our tertiary alcohol. Now, on another basis of classification, our alcohols may be classified as monohydric, that is containing one OH group, dihydric, having 2 OH group, and then the third one is polyhydric, that is more than 3 or more than 3 OH group. Now, on another basis, on the second basis of classification, we have here our allylic and benzalic alcohols. Now, in allylic alcohols, in allylic alcohols, we will see here that the OH group, our OH group, is attached to an sp3 hybridized here. Also, it's the same sp3 hybridized carbon atom, but it is the sp3. The OH group is attached to an sp3 hybridized carbon atom next to carbon to carbon double bond. And let's check out the example that is here. If we have an allylic alcohol, that is CH2 double bond CH2OH. Now we see here that this our carbon, this is sp3 hybridized, and this is known as the allyl group. Therefore, allylic alcohols are those alcohols in which the OH group is attached to an sp3 hybridized carbon atom next to a doubly bonded carbon to carbon double bond, and thus this is our allylic alcohols. Now the second example here is our benzalic alcohols. Now in benzalic alcohols, here the OH group, our OH group is attached to an sp3 hybridized carbon atom, which is bonded to an aromatic ring. Here in benzalic alcohols, our OH group is attached to an sp3 hybridized carbon atom, and this sp3 hybridized carbon atom is bonded to an aromatic ring. That is, let me write here, the example here is we have here our benzene ring. We know that all the carbon atoms in benzene ring are sp2 hybridized, but here we need our OH group should be attached to an sp3 hybridized carbon atom. Therefore, if I put here carbon atom OH, this is known as our benzalic alcohols. This is a primary benzalic alcohols. And then second example here we can take here is, if we want to make a secondary benzalic alcohols, our benzene ring, this sp3 hybridized carbon atom is attached to another alkyl group OH, and then we have here H. Therefore, this is the classification of our alcohols. Now in phenol, if we see here, in phenols are the hydroxy derivatives of the aromatic hydrocarbons, in which the hydroxy group is directly attached to an aromatic. The hydroxy group is directly attached to an aromatic ring. Thus, in phenols, the OH group is linked to an aryl group. Thus, they can be described by our general formula here, RAROH. Now, phenols are also classified as monohydric, dihydric, and trihydric phenols. Monohydric, dihydric, and trihydric phenols, according to if they contain 1, 2, or 3 hydroxy groups that is attached to our aromatic ring. Now, in phenol, if we see here, the classification is that they also have mono. The mono means we'll be having here 1 OH group attached to the benzene ring. And another such examples we can take here is here, if our OH group is here, it can be substituted also. More substitution can occur. 1 OH group, and then we can have here our NO2 also, and then we can have more substitution on the benzene ring. With respect to our OH group, we can have our chlorine atom here, NO2 also. I'll be doing nomenclature for all of these compounds. Now, therefore, in alcohols, we will see, in phenols, we will see that the OH group is attached to the sp2 hybridized carbon atom of our benzene ring, and thus they are classified as mono, di, and trihydric phenols. Now, if we check the nomenclature of our alcohols and phenols, now in the nomenclature of alcohols, let's first do for alcohols. Now, alcohols, let's take our first example for our alcohols. That is, in alcohols, the longest carbon we know in the system of nomenclature, we should always check the longest carbon chain containing the hydroxyl groups. Suppose if we have here our CH3, CH2, CH2, OH, the functional group should be given the lowest numbering 1, 2, and 3. Therefore, here is 3 carbon atoms. It is propane. Now, in the hydrocarbon, PROPANE, propane. The E will be replaced by OL in alcohols. Therefore, the name here will be PAN, propanes hyphen. The OH group is attached to our first carbon atom, therefore propane 1-ol. Now, that is our propane 1-ol. Now, this is known as N. This is the IUPAC name. IUPAC name, the common name will be N-propyl alcohol. In the common system of nomenclature, the word alcohol will be given to our organic compound, that is our alcohol. Now, if we check the second example here, we can have here our CH3, CH, CH2, CH3, if the OH group is attached here. Now, here, this is a secondary alcohol because our OH group is attached to the sp3 hybridized carbon atom, which is further attached to 2 more carbon atoms. Therefore, this is the name here is secondary 1, 2, 3, 4 carbon atoms. Therefore, it is butyl alcohol. Secondary butyl alcohol. The IUPAC name here is the name here we will be having here 1, 2, 3, 4. IUPAC name here will be butane. E will be replaced. Position here is 2 or. Another example here, CH3, C, CH3, CH3, OH. Now, this is a tertiary alcohol. The name here will be tertiary. 1 to 4 carbon atoms, tertiary butyl alcohol. The IUPAC name here will be carbon number 1. We can make it 1, 2, 3. Therefore, the IUPAC name 2. This is our. Here we have one substance here, 2-methyl propane, with it 3 carbon propane 2-ol. Therefore, the name here will 2-methyl propane 2-ol. Therefore, in the difference between IUPAC and the common system or the travel name given to our alcohol is that in alcohols, in the common system, the word alcohol will be given, whereas in the IUPAC system of nomenclature, the word oil will be added to our alcohol. Now, let's take some more examples. If we have here CH2OH, CHOH, and then our CH2OH. Here, the common name is known as GLYCEROL, glycerol, and the IUPAC name is known as mid-8-prop, 3 carbon atoms, and each of the this is a dry hydric alcohol. The 3 alcohols are attached to 3 different carbon atoms. Therefore, let's give 1, 2, 3 the numbering. The name here will be propane 1, 2, 3 dry all. Now, therefore, this is the nomenclature of our alcohols. Now, in phenols, if we check here, in phenols, the nomenclature is that, I'll take the examples here. The name here will be, this is our phenol. This is 1, 2, 3, 4, 5, and 6. The name of this, the IUPAC name here will be 2-bromo phenol, or this IUPAC name. In the command name, we will be using ortho, meta, and para positions. Now, the bromine, the substance is attached at the ortho. This meta, para, meta, ortho. At the meta position, ortho position. Therefore, it will be ortho bromo phenol. Now, here, this is our OH group is given the first preference with respect to nitro group. Therefore, this is our 4-nitrophenol. And the this IUPAC name, the common name here will be bara-nitrophenol. phenol. Now if we check the name of this, here we'll be having here our first 2, 3, 4, 5, and 6. Now the name here is our 2-chloro, 4-nitrophenol. Now if we take some more examples, we can check here for the nomenclature of phenols. We can have our OH is here. If I attach an NH2 at this position, the name here will be 1, 2, 3, 4, 5, and 6. Here will be 3-aminophenol, and the command name will be meta-aminophenol. Now another example, our OH group is here, and then let me attach an alkyl group here, CH3, 1, 2, 3, 4, 5, and 6. This name here will be 3-methyl-phenol. That's the Arabic name. The common name will be M-cresol, CRESOL, M-cresol. Now for this is the nomenclature of our phenols. Now suppose if we take a trihydric alcohol, if 3 OH groups are attached, OH, and then I have here our OH, the name here will be 1, 2, 3, 4, 5, and 6. Therefore here will be, let's take 2 and 3 first. 2, 3 dihydroxyphenol. And then this can also be represented, this cannot benzene, 1, 2, 3 dry, or this also referred to as our benzene 1, 2, 3 diol. Now the position of the 2 alcohols with respect to our main OH group can be at the para position also, or both can be at the meta position also. Therefore with this I'll be ending the nomenclature of our alcohols and phenols. In the next video I'll be explaining the preparation of alcohols and phenols.